Hey guys, what's up? Mr. Mises back here with you. We're looking at some calculus review for the AP Calc exam. So in this video, I'm going to talk about some derivatives. So how do you look at some of the information that's given on the exam about the derivative of function, the second derivative, and specifically in a table format. So I'm going to do a problem from a previous exam. This is from 1991. This is the AB Calculus number 5. So if you want to look on, if you find it up on Google or something, you can look at the solution. But I'm going to talk about what we're doing and what the idea here of the derivative and what you're looking for is going to be on the test. So let's take a look at this problem. Shall we? We shall. Let's go. So here's the problem. I'll let you get a second to read it. So pause me for a second. Read it over. So we have this table here. And this table gives us information on f, f prime, and f double prime. One of the things that the AP exam likes to do a lot is they like to start at f prime and then have you answer questions about f or f double prime. So you have to really know what you're doing in terms of what picture you're starting with or what function you're starting with and the notation. So in my class anyway, I'm going to go over another example, and maybe I'll post another video up here on another example from a previous AP exam. But for now, we're just going to take a look at this, and then I'll go over maybe a graphical representation of this. But remember that, just kind of a pro tip here, the AP exam, they like to start here at that f prime and then ask you questions about f and f double prime, okay? So you got to understand what we're talking about in terms of concavity, slope, and area under a curve. So first question here is find the x-coordinate of each point at which f attains an absolute maximum value. So we're looking for an absolute maximum value. Let me see if I can get my little highlighter here. So where it gets an absolute maximum value and an absolute maximum minimum value. So the one thing here that I want to highlight, two things I wanted to highlight apparently, but the key word here is value. Value. When you see the word value for absolute maximum value, that means you're looking at the y value. All right, so you want to know what x-coordinate, what's the x-coordinate that's going to give you a y value that's an absolute maximum or an absolute minimum. So when we're talking about absolutes, we have to look at the relative minimum or maximum, but we also have to consider our interval and our values at those intervals. Okay, so we're going to need to know what f of -3 might be and what f of 3 is going to be, because we want to know if those are going to be higher or lower than whatever we're dealing with. So, or negative or positive. So we'll take a look at when we get, we'll cross that road, cross that bridge when we get to it, okay? So let's take a look at what we're going to do first. So whenever we're asking about maximum or minimums, relatives or absolutes, we're looking at the first derivative, and we're looking to see if the derivatives are positive or negative, because we need to find out where things are increasing or decreasing. So I'm going to make a little table here. So for part A, I'm going to make a number line. And my number line is going to be an f prime number line, and I'm going to look for my possible critical values. So I'm going to look at f prime. Again, we're usually the AP exam, they want you to look at f prime first. And it's undefined at 0. Okay, so we are going to need 0. That is a critical number because it's undefined. It's 0 at x equals 1. So at x equals 1, I got a critical number here. And then it's also undefined at 2. So anywhere where I have an undefined, and I'm just going to put an undefined here. Okay, anywhere I have undefined or 0 for my derivative, I'm going to have a possible critical number. So now I'm going to check within those intervals. Now I'm going to block this off at -3 and +3 because that's my closed interval. So I'm going to check within these intervals whether my derivative is positive or negative. So I'm going to look at my table here. Between 0 and 1, I have a negative. Oops. Negative. All right, that's 0. Between 1 and 2, it's also negative. Okay, I'm looking right here. And then between 2 and 3, it's positive. So what does that tell me? That tells me that this is decreasing, decreasing again, and then increasing again. All right. What do I know about f prime went between 0 and -3? Well, let's take a look to see if we can find anything about that. Well, I do know that this function is even. So even means it's symmetric about the y-axis, right? Symmetry on y-axis. So that means whatever's happening from 0 to 3 is going to be the exact same thing as it's going to happen from 0 to -3. So I'm just going to kind of mirror this. So I'm going to need a -2 here, because that's going to give me a plus here, and then I'm going to have a negative and a negative. Actually, it's going to be, it's got to look the same, right? It's got to look exactly the same. So it's a mirror image. Hold on. It's a mirror image, so it's going to go like this, and then it's going to go like this again, okay? Because it's got to look the same, right? Symmetry about the y-axis. So actually, it's increasing here, and then decreasing there. So it's symmetry about the y-axis. So now that I know what the function is basically going to look like, let me find my absolute maximum value. So where could that be? That could be right here. There's a relative max. Right here, or right here at -3. All right? So let's take a look. What I'm really looking at is, now that I know that that's going to be my maximum, I want to know which value is bigger, f of -3, f of 0, or f of +3. Okay, well, I know that f of 0 is equal to 1 because it tells me it right here. So now I'm looking at the f, okay? F of 0 is equal to 1, so that's, I got a lot of things circled here. All right, let me uncircle things now so we can see what we're looking at. Okay, f of 0 is 1. Okay, what's f of 3? Well, f of x, let's go to 3 here, is going to be negative. So f of 3 is going to be negative. So that's got to be smaller than this one right here, right? And if it's symmetric, then this has also got to be negative because it's got to be down there. So these guys are going to be smaller than that. So right here is my absolute max. Okay? What about my absolute minimum? Well, my absolute minimum could be here at -2 and here at +2. So which one is it? Well, let's take a look at what f says. F at 2 is -1. So f of 2 is -1. And since this is symmetric, f of -2 is also -1. So the absolute minimum is at x equals both of them, plus or minus 2. The absolute, I'm going to have to say it, hold on. Your answer right here should be absolute max at x equals 0. All right, you want to make sure that you say, because it's asking for the x coordinate. All right, so part B, find the x coordinate for each point of inflection. So points of inflection, how do we find points of inflection? We look at second derivative. So we want to know where the second derivative is equal to 0. So where is the second derivative equal to 0? All right, so I'm going to erase all this now. And we'll. All right, so now we're looking at the second derivative. So we're looking here now, second derivative. And we're going to find out where that is 0 or undefined. So now I'm going to make another table. This is part B. I'll make another table this time for f double prime. I'm going to go from -3. And let's see what we have here. We have undefined at 0. We have 0 at 1 again, all right. We have undefined at 2. And then we'll go to 3. And so I'm going to mirror this time. I'm going to go all the way like that. Okay, so it's we've got positive between 0 and 1, negative between here and here. So that's going to be concave up, concave down, and then negative again. So it's going to stay concave down. That means it's got to go... it's got to be mirrored image on the other side, right? Okay, so it's got to go like this, and then like that again. So what do we got here? So we're looking for an inflection point. Find the x-coordinate inflection. So where does it change concavity? Well, this goes concave up. This is still concave up. This goes concave up to concave down. So right there, and then right here at -1. So we've got... So we say f double prime changes sign at x equal 1 and -1. Okay, we got to tell them why it's an inflection point. So when we justify our answer, we can't use just the number line to justify it. We actually have to say F double prime changes sign. That tells us that we understand the calculus of why things are inflection points. Okay. All right. So part C now is to sketch the graph. So I'm going to do a quick sketch of what's going on here. All right, using what we had before. All right, so we have f of 0 is 1. So f of 0 is 1, so I'm going to go right here. And then I also know that f of 1 is 0. So that's right here. Okay, I got this from this information right here. And f of 2 is negative 1. Okay, right there. It's got to be the same on this side. And we already noted that it's going to go decreasing, increasing, decreasing, increasing. And then we're going to follow the concavity. So it goes concave down, then it goes concave up, then concave down, and then concave up, like that. Actually, it goes concave down. Right there, concave down. And then it goes concave up on this side, concave down again like that. Dude, I cannot write right now. Sorry about that. Concave up. All right, something like that. I think they'll be okay with that. You know, your handwriting doesn't need to be perfect. Let me zoom in here. Like that. Okay, just as long as you show the concavity and you get your points in the right place that were given. All right, so that's an example of a problem from the AP exam in which we're using the information given in a table or the information given to answer questions about f prime, and f double prime. All right, guys, we'll see you next time. Good luck on that AP exam. You're doing good. Bye.